Hi, this is Dr.G.Vikas. In this session, we'll discuss few problems on strain energy. So, first problem is a steel bar of 50 mm by 50 mm. Okay, there is a steel bar of 50 mm by 50 mm in section and 3 meters in length. Okay, 3 meters length, and is subjected to an axial pull of 140 kilonewton. Okay, and calculate strain energy stored in the bar due to the. So when the load is applied, there is some strain energy developed in the body. We need to calculate the strain energy stored in the body. Also find extension of the bar. Okay, so due to this force load, then there is some extension. So this extension delta L we need to find. Take E equal to 200 GPa gigapascals. Okay, this is your dimensions. Now L is given as 3 meters, so 300,000 mm. P is 140 kilonewton or 40 to 10 cube newton. We need to find U and delta L. E is given as 200 gigapascal, 200 into 10 power 9 newton per mm square. So here the type of load is not given, whether it is sudden load or sudden load, gradually applied load, or impact load. So we are assuming it as gradually applied load. Assume the load as gradually applied load. Stress. So for gradually applied load, sigma equal to P by A. So sigma equal to P is 140 into 10 cube, A is 50 into 50. So strain energy formula U equal to sigma square V by 2E. So sigma already we have calculated. Okay, so substitute this one here. So this is into V is area into length. 50 into 50 into length is 3000. Divided by 2 into E. E value is there already. Okay, so you will get this one. This is the answer. Then calculate delta L. So delta L is nothing but PL by AE. Okay, so PL by AE is equal to 140 into 10 cube into 3000 into 50 into 50 into E. E is 200 into 10 power 9. So we will get this answer, delta L. Let us discuss another problem. A mild steel plate is 400 mm long, 200 mm wide and 50 mm thick. Is subjected to, what is the dimensions? 400 mm long. Okay, this is 200 and this is 50. Okay, 250. Okay, is subjected to gradually applied load. So the type of load here is gradually applied load. That means sigma equal to P by A. Okay, what is the load? P given 1200 kilonewton. 1200 kilonewton means 200 into 10 cube newton. Length is 400 mm. Calculate first one, proof resilience. Second, modulus of resilience. Third, elongation. Take E equal to 200 into 10 cube MPa. Okay. Proof resilience is nothing but strain energy, maximum strain energy. Okay, U max equal to sigma max square into V by 2 EI. So sigma for gradually applied load, sigma is nothing but P by A. Okay, first we will calculate sigma P by A. Then substitute this here. So U equal to sigma square V by 2E. Sigma square, this is V, area into length, by 2 times E. Then you will get strain energy as this one. Modulus of resilience. We know that modulus of resilience equal to U by V, strain energy per unit volume. So this is sigma square by 2E is the formula. Sigma already we have calculated by 2 into E. And third one, delta L equal to PL by AE. You can write sigma L by AE also. So sigma is 120, L by E. So 0.24 mm. Next problem is a steel rod of 400 mm in diameter. So it is a circular steel rod. What is the diameter of this one? 400 mm. Okay, 400 mm. What is the length? 2.5 meter. Okay, now find the maximum instantaneous stress induced when a pull of 80 kilonewton is applied. The 80 kilonewton is applied. We need to find the instantaneous stress induced in the body for two cases, that is for gradually applied load, for suddenly applied load. Also find the maximum instantaneous elongation. So delta L for first case and second case we need to find. Take E equal to 105 GPa. Okay, here he is not asking to find U, he is asking to find only delta L, elongation, not strain energy. Okay, so all these are given data. Okay, delta D, L, P and E. Okay, giga, therefore 0.49. We need to find stress and delta L. First case, gradually applied load, sigma equal to P by A. Okay, area of cross section is, it is circular here, therefore pi by 4 d square. Instantaneous elongation, delta L equal to PL by AE, or we can write sigma L by E. So sigma is already calculated, sigma into L by E. This is the answer, delta L. For next case, suddenly applied load, we know that sigma equal to 2P by A. Therefore 2 times this answer, 63.66. Or you can write again. So delta L equal to sigma L by E. So this is a sigma here. So sigma L by E. This is delta L. So stress and deflection in suddenly applied load is double the stress and deflection in gradually applied load. Next problem. Determine the instantaneous stresses and deformation of a rod of 1 meter length and 6 mm diameter. Okay, what is the length of the instantaneous stress and deformation of a rod of 1 meter length. So what is the length of the rod? 1 meter and 6 meter diameter. 6 mm is diameter. If a mass of 50 kg falls through a height of 10 centimeter, so mass of this one, this is the load. Okay, what is the mass given? 50 kg falls through a height of 10 centimeters. Okay, so it is falling on the collar. What is height? One height of 10 centimeter, and sticks the bottom of the rod. Okay, find the, what we need to find here? We need to find the stresses and deformation. Stresses and deformation. Sigma and delta L we need to find for this case. Okay, diameter is given 6 mm, length is given 1 meter 1000 mm, mass is given 50 kg, height 10 centimeter, 100 mm, E equal to 210 into 10 power 3 Newton per mm square. So type of loading here is impact load. Okay, for impact load we have the formula sigma equal to P by A plus under root P by A square plus 2 PHE by AL. So what is P here? Load is nothing but weight. So mass into acceleration, 50 into 9.8, 490.5 Newton. This is the P. Next, so here we have substituted P value, here area. So P by pi by 4 6 square. This is 6 mm, right? So pi by 4 6 square, same. P we already calculated. H is 100 and E and A into L. If we solve this, we'll get 1.17 Newton per mm square. And instantaneous deflection delta L equal to sigma L by E. Sigma L by E. Okay. So we'll get delta L as 4.15 mm. Next problem. A vertical steel bar 15 mm diameter 1.4 long. Okay. This is a vertical steel bar of 15 mm diameter. What is the diameter? 15 mm. 1.4 meter long. 1.4 meter long. Is provided with a collar at lower end. There is a collar at lower end. Find the maximum weight. We need to find the weight in this question. That can be dropped through a height of 95. So this is the height over the collar if maximum stress is 150 MPa. Here stress is given that the maximum stress is 150 MPa megapascals. So take E equal to 200 GPa. Here we need to find weight. Okay, same formula we need to use. So D area pi by 4 D square, sigma is given, E is given. This is the formula. So everything is given. We need to find the, what we need to find? We need to find the load. Okay, here P we need to find. Okay, P we need to find. Here what we have done, we have substituted P by A as X. So this is 150, this is X, and everything is there. We can substitute here. Okay. Here also P by A is there. No, instead of P by A we are substituting X. Okay. Now if we simplify it, we'll get X as 0.82. But what is X? P by A. So P by A equal to 0.82. P equal to 0.82 into area. Area already we know. Area already we found as 176.7. Substitute here, we will get the load weight 144.98. Thank you.